For our semester project, we decided to 3D print salt and pepper shakers. Most of us had very little experience with 3D printing and wanted to gain a better understanding of this up-and-coming technology. We chose salt and pepper shakers to show that many common household items can be made using this new technology of 3D printers.
Before we started printing, we had to make a sketch. We used Autodesk Inventor to make our initial design, which was 2 cylinders with 2 parts, the top and the bottom. The bottom part was 2.57 inches tall with 1.75 inch diameter, and then the top part was 1 inch tall with the same diameter. The cap had a total of 19 holes for the salt to come out of, and each hole had a diameter of 0.21 millimeters. In order to make them holes and not solid, each circle was extruded to the top part of the cylinder, cutting away all of the excess drawings. And then next, an inner circle had to be made on both parts with a diameter of 34.42 millimeters and was extruded up and down, but we left a thickness of 7 millimeters on the top and the bottom to ensure that the salt would be held properly. And then for the threading, a circle was drawn in between the inner and the outer diameter on the bottom piece only, and it was extended up 0.25 inches, allowing us to create the thread. And then for the top, we just used the thread tool on the inner diameter, and then after doing that, the drawing was complete.
For our second design, we decided to go with a more complex shape, more of an hourglass type of figure. So we had to model that up in Fusion 360. We started with a 44.75 millimeter base, and we drew a 69.85 millimeter line from the center of that circle to give us the full length of the salt and pepper shakers we were making. We then added 2 more circles at 34.75 millimeters halfway up and a 54.75 millimeter circle all the way at the top. And then we used a polyline tool to create a curved line and revolved it around the center of the circle to create the hourglass shape that you see. And then we kept the processes the same for the threading, the holes, and the fillets from the previous design that we used. And that's about it.
Okay, so in one print, the bed was too cold due to the ambient temperature. So, got my bed here. Perhaps here's the print, and the ambient temperature was too cold. So as a result, the plastic began to curl upwards. So what this looks like here, got our bed here. And as this is going up, it begins to curl inwards like this, creating sort of a frowny face shape. And the hot tip, which is right here, has to really force itself on here. So as a result, you can see down here, the print ends up shifting over this way, causing sort of a lopside in our cylinder, bunch of stringy stuff was meant to be in the print, but unfortunately got shifted over, causing a failure in our print. Second attempt, our initial design was too big in AutoCAD, which means the print would have taken upwards of 36 hours, leaving much room for error. We ended up starting it anyway, and the print sure enough failed due to curling once again. So we made our final design much smaller, which turned out successful. So some of the lessons learned here was make sure that the climate of the room is roughly the temperature of the room to ensure that no curling happens, and also having print sizes reasonably small to eliminate long print hours and machine error.
Here we have the 3D printer. The orange filament is located on the spool to the right side of the printer. This is what the 3D printer uses as the building block of whatever it is that you are printing. The clear platform on which the orange filament is being extruded onto is known as the bed. The print bed is set to 70 degrees Fahrenheit, and the hot end of the extruder starts at 195 degrees and goes down to 180 degrees after the first layer. The room temperature was at 67 degrees Fahrenheit at the time of printing, and the extruder can be seen hovering above the printing bed. The initial speed of the extruder was set to 55 millimeters per second. 3D printing is essentially an additive process of making a three-dimensional object from a digital file, which will be a 3D CAD model. We used a STL file, which we uploaded into a slicer, which was Cura. The 3D printer extrudes molten plastic through a tiny nozzle, or the extruder, that it moves around precisely under computer control. One layer is printed, and after that layer dries, the next layer is printed on top. This process continues until the print is done.
We hope our project has given you a better understanding of the 3D printing technology like it did for us. Our group very much enjoyed learning about the 3D printing process and hope this will help us should we need to 3D print down the line in our careers.